All right, I'm recording it. So I have Luke in the room. This is Daniel. And the purpose of this ScreenFlow recording is to go through SAS code for the CMS HCC algorithm and explain it in full so that I myself, Daniel, if I need to look at this in a few months and I haven't touched SAS code in a while, can re-understand it. Two purposes here. A, kind of a mini tutorial on SAS and all its interesting foibles. And B, did I say A or one? A, the tutorial on SAS, and B, a walkthrough of every last line of code in here, because I'm going to need to translate this into Python for now, eventually R. The idea is to expose the algorithm and let the language be determined later by someone else. Luke, feel free to interrupt and ask any questions. In fact, I want you to. I want you to say, what is this exactly? So for me, when I approached this, I didn't feel comfortable. I sort of understood the large brushstrokes. Yeah. But I didn't feel comfortable just sort of ignoring large bits of syntax here, because they could be, especially with an ancient language like SAS, yeah, they could have extreme consequences because there is some sort of random meaning that I was missing. So it is actually, turns out, very simple, and you'll probably say, yeah, that's it. It's just that simple. But for me, I didn't feel comfortable until I could, pick a random little bit of syntax, like especially like right here, which is insane, and understand every last token, every last lexical implication there.
So there's, and a couple things that I want to do as we go through this is that, one, I'd like to tease out a little bit of how the right way to interface with this is. Mm-hmm. And we'll get to that as we go.
When you say the right way to interface with this, as in the algorithm?
Well, like if I were an analyst and I want to use our package, why is our package, besides not being in SAS, our package should have features that make it easier to use for different purposes? Sure.
At the very base there, our package will have basic names that make sense.
Yeah.
So for instance, SAS, coming from a legacy of like the 1960s and 1970s, has limitations to the size of variables and things like that. So you see some odd naming conventions, some really idiosyncratic functions that do certain types of things. For instance, right here, this is quite, essentially, just to kind of jump way ahead right now, that line is a dictionary lookup. That's all it is. It took me a long time to figure that out, but that's all it is. This is the crosswalk.
Yeah.
What's happening here is, here's your diagnosis, and here is your code category.
Yeah. Okay.
And it does this through some sort of weird usage of what are called formats. Yeah. It's actually explained right here. Table lookup. There are a lot of different ways to do table lookup in SAS. They actually have SQL, they have merge statements, but what they're using here, what CMS is using here, is this format procedure and put function. And what we'll find often is it seems like CMS purposefully chose to do the older way of doing SAS. There are a lot of things in here that newer versions of SAS version 9.3, have more modern ideas. They actually have things like hash tables, or they have better arrays, but this code uses like the older way of doing it. I suspect because there's a huge install base of SAS code that's not the most recent.
Yeah.
SAS licenses with SAS platforms that are not the most recent. As another example, here's a random bit of syntax right here, array. Okay, I looked at that and I wanted to make sure I understood every single, like I said, idiosyncratic lexical meaning here. So I picked up an article on arrays, and none of it looks familiar until I got to, because the way they describe arrays is it looks like this, and that doesn't match. But then if you scroll down and you get to page 6, they say explicit versus implicit subscripting. And apparently implicit is it's a cryptic way of doing it, but it's an old way of doing it. So this is the old way of doing it. And of course, and I say of course kind of snidely, this code uses that technique.
Yeah,
okay, so top level here, there are a lot of different pieces of SAS files that all together compose the code. When CMS printed this out, they actually included a PDF that explained everything. It's called HCC software version 2, whatever. It's very good. It explains every single thing in it, what every single file means and what is contained in every single file. And then it has sort of like the overall algorithm, which is very useful. And I will say this, for as much as the SAS code is crappy, it's crappy because it's SAS. I think the people who actually wrote this did probably as good of a job as you could possibly do with SAS. So I think they were excellent programmers. But SAS itself is just, goodness gracious, a pain. So some key first statements about SAS. A, there are only 2 data types, numeric and char, and that has implications here. Okay. It's an old way of doing things. We're gonna have to see coercion of variables into ones and zeros to be true and false, and that's a huge thing in here. That's because we only have numeric. We have no Boolean type in this programming language. That's a big thing. Another thing is there are really only two high-level abstractions in SAS, something called a data step and then something called a proc step. The bulk of this code exists in what is called a data step. So if you see here, data starts on 169 and it goes down to, I've annotated up another piece of paper so I know exactly where it goes. It goes all the way down to 439. So right there, that run statement is the thing that is kind of like the do end or the end squiggly bracket, beginning squiggly bracket. So what we're in right now is a file called v2.11.6h1m.sas. It's really kind of the heart of the entire program. But where you start running it is this one, which is called v21.16h1p.sas. And all it is a wrapper ultimately around a macro call to this. So let me actually return to what I was saying. So SAS, numeric char, that's one thing to know it. 2, data and proc steps, and that's basically all a SAS is, a whole bunch of data steps and then maybe a couple proc steps. 3, there is no sense of abstraction in the sense of creating user-defined functions. Like in Python, you say def, create a function. R, you can do the same thing. C, you can do the same thing. SAS comes from such an old legacy that in order to do that, you have to use what are called macros. A macro is literally a textual substitution of some code that you want to use again and again and again. So whenever you see this, whenever you see a percentage, that's a macro call. What this one is saying, I'm calling the macro call let, and it's defining some macros. I don't have time to get into too much of the details here, but basically, as your eyes get used to looking at this code, anytime you see two different types of characters, you know you're dealing with macros. A percentage sign and an ampersand sign. A percentage sign is like calling a macro function, and a ampersand is kind of dereferencing it. So when I see this, for instance, I see ampersand and that thing right there, HCC v21 list 87, that means before the code is even compiled, that's going to be expanded out into some text. And where is this thing defined? Well, this thing is defined right there. So literally, it's as if we were to take this code here, all these characters right here, and take this right here and replace it by copying it in like that.
Okay. So
that is what a macro does.
It's not referencing an array. It's actually just representing a string of that stuff.
Exactly. That is not an array. Well, you can conceptually treat it as an array, but it's not. You can't access, index, whatever. It literally copies and pastes that right there. So anytime you see an ampersand, imagine you copying and pasting. That's actually what happens. Before it gets compiled, all those ampersands are dereferenced and exploded, right? So that is, I'm familiar with macros, and the problem with macros is they create a separation between language and meta language. Macros are a meta language. They are a language about the language. And this used to be the way people did abstraction in some really old types of languages. Unfortunately, it's not the best here. You can't create user-defined functions unless you use macros. Okay. So there are a lot of idiosyncrasies in here. And so this is a macro call. So again, there are two different types of macros. Let me be explicit with that. Macros that are defined with this let can be dereferenced with this ampersand right here. There's another way of defining a macro, and that's kind of like a function macro. And those start like this. Percentage sign macro, and then the name of the macro. And then they have at the very end, they have a percentage mn for macro end. Those types of macros, let's call them function macros, you call by invoking a percentage sign and then the name of the macro right there. Yep. So this v2.11.6h1m can only be called because someone defined the macro v2.11.6h1m.
What's the line before? Go back to P. What's the line before then? Or it's like divide by source 2.
What this does is it literally includes the location in 0 right here is the location of the file of the directory in which, so this is some weird syntax. This says in this directory in 0, and then they have a parentheses, look for this file. /source2, I believe means it's not a divide sign. There's a lot of weird syntax that's specifically hard-coded into SAS. I believe it's saying treat it as source when I include it and don't try to pre-process it. Okay. I think that's what it means. I say I understand this 99%. That's one of the 1% I don't.
Yeah, I mean, that makes sense. Include.
Yeah, okay. And a lot of this was, I was sure of these things, and some of these things I didn't dive too deep into, but I'm sure that's what it is. Okay? Yep. So again, even though v2.11.6h1p.sas is the main line, it's essentially, look at all this, from here to right here, it's just comments. Yeah. And then we're setting some certain variables, and then we call the main function, and I put that in scare quotes because it's a macro, and this is it. And this main function is the guts of the program. Every other macro is called from here. And as I mentioned before, all of SAS is a intermingling of data steps and proc steps. And literally, this program is 98% data step, because at the very end, here's the end of the data step. Your proc step is literally just printed out.
Okay.
Because the end result is a table, right? Yeah. Okay. So understanding the data step is critical to understanding SAS. Every SAS tutorial you read says that same thing. And when people talk about the power of SAS and how powerful and wonderful it is, what they're really talking about is actually a bunch of pre-written proc steps that allow you to do statistics. But it's the data steps that allow you to pull in data from some other location. And it's also this data step that there's a lot of weird old legacy stuff going on here. So a data step starts like this: data. The name right here is the name of the output data set, and that's unfortunately took me a while to figure out. So this is a macro right here, out data. Well, where did we get out data? If you scroll up, you can see that it came in as a parameter. Well, that was the third parameter we passed in. Out data is equal to out to. I actually coded this. I set this. Yeah. I set this, I set this, and I set this. So what I'm saying is there is a library called out. A library is just a directory where data files go. And you can see right up here, libname out. And this is the location. This is the directory it's going to be. So I'm saying this is creating a permanent, what is called a permanent data set. Data set is a very specific thing in SAS. A data set is just a table, but it's a SAS specific format. So, even though the phrase data set sounds informal, yeah, it is a very specific thing in SAS. It's literally a format of data columns, rows, and some sort of metadata, including formats, which again, a format has a very specific formal meaning under the SAS programming language. So right here, data, what we're defining is the output location for all this data. I'll not explain it for now. So here is probably the most important statement about data, the data step. This data is like an implicit for loop.
Okay.
So when you write a for loop in any other language, you're saying iterate over something, and then you indent it. Yeah. And all the stuff inside that code block is what you do every single time.
So this is like for out data, do everything.
Exactly. So everything from line 170 down to line 438 is like the block of a for loop.
Okay.
Right?
Yeah.
We saw the same thing with awk. Remember when we ran awk and we gave it those patterns? Yeah. We were implicitly, those blocks of code were running on every single line. And this is because SAS comes from a heritage of you're streaming data through here.
Oh, okay.
Right?
So is it every line of which input?
That's exactly what made me tear my hair out. Where the hell is the input? There is no very easy way to say what is the input. Most SAS uses something called a set. You would actually literally write something like this: set, and then you give it a libname dot whatever, and that would become our input. In this case, our input is right here.
Merge the two inbound files on the ID variable.
Yes. So there are multiple reserved words, keywords, that explicitly / implicitly create the input upon which this data step loops. Merge is one of them. Merge allows us to set two different data files together. Here's another one. There's the set. Remember, I was saying I wanted to understand every single line here. This is also a data set. InCoef is a library. HCC CoFN is a permanent data set. I don't quite get why this is a reserved word _n, but it basically says if this is our first time through this implicit loop, then do this. And what are we doing? We're setting. Set is basically like, what's my input? So actually, there are three inputs here. There is this one, there is this one that are getting merged together, and there is this one. But for some reason, this one, well, actually, it's always going to be fixed. This one, right, it doesn't get iterated for some reason. Okay. Whereas these get iterated. Okay. So I mentioned to you before, the CMS HCC SAS code tends to be older level code, and you can see that here. Merge by IDVAR is an older way of doing it. You'll notice over here when they explain what kind of code you want to, when they explain the code and how you want to use it, they go down here and say file supplied by a user. 2 SAS input files needed for the software must be pre-sorted in ascending order. That's key. I had to pre-sort these things. I had to make sure that if patient ID 1 was in the beneficiary file first, before patient ID 3, then in the diagnosis file, that same sort order was present. Why? Because this merge requires it.
Yeah.
And this shows you a little bit of the heritage of the old ways of doing things. By requiring that these two files be pre-sorted, merge is very much doing a join, like a relational SQL join. So in fact, there is a proc in SAS that allows you to embed SQL. And we could have done it using that, but I believe CMS says, oh, some people don't have version whatever 5.3 in which proc SQL was introduced. And so rather than requiring people to upgrade, they have this old way of doing it. So you have to pre-sort the data so that this merge can occur.
Okay.
And so what's actually happening here is this macro, %INP, that comes from right here, which is the very first thing we passed in, which was in1 2010 bene, which is the beneficiary file. In D, which is P means patient, D means diagnosis. So there you go. Those things become, back in the merge statement down here, those things are expanded out. And literally what's written here is in1 dot underscore 2 2010 bene or something like that.
Yeah.
That's an important thing to realize. But you notice this in1 right here? That's not the same thing as this one right here, which took me a long time to figure out. So this syntax right here is a special way of indicating to yourself whether there's anything present or not. So if we're joining two files and we're joining them by ID var, it's possible one of them doesn't exist on the left. Left outer joins, right outer joins.
Yeah.
So this is SAS's way of saying if in1 is equal to 1, then it's present. If in1 is equal to 0, it's not present. If in2 is equal to 1, that record, the right-hand record, is present. If in2 is equal to 0, it's not present. Okay. So that's what that means. So then you see right here, line 216. Line 216 goes all the way down to 438, which is almost the entire data step. So this line right here is protecting us and saying, if in1, so it's basically saying, if I have a beneficiary, then do this. If not, do nothing.
Okay.
So this is a little bit of a protection. You see, you can do it in
Yeah.
Python code easy enough. That's what that means. So that makes sense. That's protecting us against there being a diagnosis with a patient ID who's not in the beneficiary file, right? Okay. Now, so everything, as I was mentioning here before, everything here is implicitly in a loop of this beneficiary. There is always just one beneficiary row, and therefore there are multiple diagnoses roles. So we're going to be iterating over multiple diagnoses across multiple beneficiaries.
Yeah.
Okay. So they do a pretty good job here explaining here. There are three kinds of things that go on here. There's the first record. We do some initialization. This is step 3-4.
Yep.
This only occurs for the first record. Then there's stuff that only occurs for the last record. This goes down to right here. So this block of code, it only occurs for the last record. And then this stuff here, step 3-5, occurs for each diagnosis.
It's just weird because it's like, normally you just have a for loop. The for loop would end and it would move on.
Yes.
Instead, it's like, be aware when we get to the last record, do everything else here.
Yes.
And it's because of the way the data step works.
These are the foibles of an old programming language that has a heritage in COBOL. Yes,
Yeah.
The data step is different. And I've read a lot of papers on it, and almost every single paper that anyone writes on SAS begins with the phrase, the so-and-so feature of SAS is a very misunderstood but extremely powerful feature.
Sure.
They all start that way. And they all are powerful, but I would argue that every Turing complete language is powerful. Yeah. So there's a lot of Stockholm syndrome going on when you read all these academic papers on how to do powerful things in SAS. So let me repeat here. Step 3-4. This is done for the first record of that beneficiary. This is done for every record of the beneficiary, every record, not just the first, not the ones that are neither the first or the last, but every record. And this one is only done for the last record. Okay. Yep. So a couple more syntax things right here. Length. Basically, anytime you reference a variable and it's on the left-hand side of an equal anywhere in this code, for instance, like right here, it will be implicitly put as the output. So there are dozens of different ways to say things are in the output. This is the main one. So this says keep var is actually a mixture of these plus these macros, and that's because in the end, what we're really printing out is per patient we're printing out like 300 columns. And these are here. These are the patient ID, these input variables. The input variables are things like age, date of birth, that kind of stuff. Score variables, the 3 scores you get: community, institutional, and new enrollee. Demographic variables, which age bucket they're in. And it's not that they print out one. They literally print out every single age bucket here, every single one, and they put a 1 to indicate that you're in it and a 0 to indicate if you're not.
Right.
Which is odd, but it also makes sense because what they're doing from a scoring perspective is creating a linear regression function, which is literally every single one of these things, these demographic variables. And if it's a 0, then it adds nothing to it.
Right.
If it's a 1, it adds something.
That's what made it so much easier to. That's what made it so easy to take the raw output and rerun a regression.
Yes.
Because I just had to.
You had to add a new coefficient.
And that was it. And then just relinearize.
Yep.
You know?
I needed to go through this code and verify that for myself, but that's absolutely all it's done.
I didn't really know that. I just figured,
But that is exactly what's going on.
Yeah.
And I'll get into more details with that later on. So back to the point though, what is output into the data set, into this data set, is a combination of what's in this keep var and anything that's implicitly here. So you have a statement like this. Unfortunately, as I mentioned to you before, SAS only has 2 different types, numeric and char, but it also limits them. Again, heritage of COBOL. You recall the year 2000 crap. That's because back in those days, people only set aside 2 bytes for the 2 numbers of the year. Yeah. They didn't set aside 4. Most modern programming languages, an integer is an integer. It can be infinite, right? Yeah. In SAS, as an older language, you actually have to explicitly say, kind of like in some databases, this is a character that can only be 4 characters long. This is a string that can be only 4 characters long. So that's what's going on here. We're saying length. Category. Whenever you see the $sign, that means we're dealing with a char type. So what we're saying here is all of these things are an alternation of the variable followed by a format. So in this case, the variable is CC, which is code category, and our format is it's a character 4 long. The dot is just needed there. In the case of a numeric, the dot means it doesn't have a digit following after it, but it's just always there. Age F, no $sign there means this is a numeric, and it has 3 digits, right? Because no one is more than 999 years old, but there are occasional people who are 105 years old, right? Yeah. The dot indicates, if there were a 2 here, it would indicate that there are 2 things after the digit, but they're not, right?
Like float 3, 2.
Yeah. Okay. All of these continue to be variables, and all of these have this format assigned to them.
Oh, okay.
And then occasionally you have things like this right here, which creates a range. So from HCC1 to HCC what? Well, that is a macro that gets expanded. Well, where does that macro come from? That macro comes from
up at the
201. So literally that 201 right there gets substituted in right there before compile time. Boom. And this dash implicitly creates an HCC1, an HCC2, an HCC3, all the way to 201. So you see that a lot. There's a mixture of meta language and language simultaneously. It's kind of difficult to read. Okay. So this is basically saying these variables that I know are going to be on my output, here are the formats I associate with them. Okay. Retain is a special keyword. Implicitly, if the data is coming in from an outside, from input right here, it's retained automatically. As we go through the for loop, we still have the old one present for one iteration so that we can add it to a growing total and create an average or something like that.
Yeah.
In the case of a variable that doesn't come from the input, like this, CC1 through CC2, whatever it was, 201, we have created these variables, but right here, we created these variables and we gave them a numeric, but they didn't come from the input. Therefore, we have to explicitly retain them so that each time we go through the for loop, they are not reinitialized. So, but we retain them, and the very first time we use them, we set them to 0. That's all this means. We're also retaining this variable age F because why? Because each time we hit a new beneficiary, we calculate the age at the very beginning, and then as we loop through the diagnoses, we still need that. So that's what this retain does. And then we have arrays. We have 2 types of arrays. We have the CC array, which is code category, and we have the HCC, which is the hierarchical code categories. This took me a long time to figure out. We're declaring the existence of an array that you can index by a numeric, but the actual values you can then say use these to get at it. So that's why these things exist here. And this is that. Let me switch over here. This is that implicit array explicit versus implicit subscripting. So we're saying array. Our array name is C. Over here, our index variable is something that ranges to 201. And then our initial array elements, our array elements are CC1 through CC201. And this allows us to reference them by going C, CC2, CC3, C parentheses, CC2.
That's kind of a cool feature.
It's interesting. I haven't seen it done before, but why, when I first was trying to understand how this retain thing worked, it didn't make any sense how it was retaining, because it looked like to me we're retaining this, and yet C was the thing we wanted to retain.
Yeah.
But it works backwards. Because we're retaining these elements, the C is implicitly retained each time through.
So it's like both a list and a dictionary.
Yes, that is correct. It's
Because
both a
you
list.
can access them by position or by what is essentially a key name.
Exactly. But the important thing for this,
Yeah.
the important thing for this is because I have retained these through each step,
Yeah.
I retain the entire array,
Yeah. Okay.
which is very critical for what's happening in that for loop.
Yeah.
Okay. So let's just start here with what's the meat of what's going on here. The very first time through, the first time we run into a new beneficiary. That's what ID var is, a macro. That is the fourth one here, which is HICNO. So that is the patient ID. So when we first see that right there, zero out the code categories. This is the first time, okay? And calculate that person's age. Easy enough. This is crazy stuff, but we understand what it's doing. It's based on the date of birth, and based on when we're running this, it calculates the age. This is the very first thing. So basically, set all the code categories to 0. From here to here is what we do on every single line. And that's all it's doing is saying, okay, what's the diagnosis? Get its code category. So that's everything here. So if the diagnosis type is an ICD-9, then do this. If it's an ICD-10, then do this. And if you look at the difference between these two things, they're almost exactly alike, except this says edit MAC 9. And this says edit MAC 0. This says FM name 9. This says FM name 0. This says I9. This says I0. But otherwise, they are the exact same block.
Isn't there? Did we feed in the diag type?
The diag type right here. Where is it? Diag type comes from here. It specifically comes from here, the input diagnosis. So if you look over here, when we were asked to feed in 2 files, we had to fill in a person file, which has HICNO, sex, date of birth, Medicaid, NMCAID, OREC, and diagnosis, which has HICNO, diag, and diag type.
Oh, okay.
It has to have diag type.
I thought it had identity logic. That's okay. Great.
So that diag type is very explicitly a column in a data set. Again, the formal definition of a SAS data set. Before even using this, remember, this is my diagnosis data set. I actually had to create that from text. So if we were to open up this right over here, right, let me pull up a beneficiary. Oh, that's the beneficiary file. Here is a diagnosis. You will see it literally features diag underscore type. That is the name of the column. That's the metadata associated with a formal SAS data set. So yes. So again, this if block and this if block are really essentially the same, except one is for ICD-9, one is for ICD-10. They could have had a macro creating a macro, but that gets really, really complicated. So I appreciate that they didn't try to get too clever here. So if it's an ICD-9, so here's all what's going on, right? So as we go through every single diagnosis for a beneficiary, we're going to do 2 things. We're going to edit, and then we are going to look up the category based on the diagnosis. Just 2 things again. Edit, and then look up the category. And edit kind of looks up the category. So, but the heart of it is right here, is looking up the code category based on the diagnosis. And this is what I was telling you before. This monstrosity right here is a dictionary lookup. That's really all it is. It took me a long time to figure that out. I could show you the details of it. But essentially put coerces, put is used. So this, we're saying right here, $I9 followed by this macro. And the reason there are 2 dots is just forget about it. It took me a while to figure out why there are 2 dots. Essentially, this second dot means end of a format. This first dot has to be there to protect this macro from seeing that second dot.
Yeah.
So this FM name 9 is actually this right here, Y2111 FIRC. So if we go back down here, that is literally substituted in for here. And then this entire thing is what's called a format, which is an external file that the documentation indicates is stored, has been created in a what is called a format transport file,
Yeah.
and that we have to load in. This is the name of that format transfer file.
Yeah.
It's an external binary SAS-specific transport file that contains all of these formats in them.
So something about this macro is, so the biggest thing with ICD codes is they're of variable length, right? Because there's optional elements at the end, especially in ICD-10. And there's a period, usually, that, but you can not have the period and immediately derive where it is. So it's not usually critical to have it, right? So an ICD-10 code, that's only 3 digits, the period is last. It's always the 4th character, right? Same, and that's actually the same in ICD-9, right? So when you port this, so like some question will be, do you want to specify the format the ICD code should be in and enforce it, or specify what it should be and then be able to fix it if necessary?
My read on this is we specify the format. If what I've seen them show, I'll show you right here, is ICD-10 codes are always like this. As I scroll down, ICD codes are on the left.
Yes.
And there were dots there, but you can sort of force it, say it has to be padded with a 0 or something like that. Once we enforce this, I'm sorry, we will not, from a library perspective, offer any transformation for people to put in their version. They need, whoever's using our code, needs to convert their ICD-9 or ICD-10 codes into a format like this. That's on them to do.
Okay.
It's too much, and it's an issue of documentation to make sure that they do it. These are the ICD-10 codes. Oh, these are the ICD-9 codes, same thing.
Yeah.
And you'll notice, of course, that there's 0 justified in order to disambiguate the differences between 323 and 00323,
Yes.
based on some dot that was there previously. I believe this one is actually going to be like this, like something like that.
Well, no, so the real issue is that there is, the reason they need to do it like this is like there is no, like look at 038, there is no 038.7. That's an invalid code,
Okay.
right? So they're very like judicious about, so it's not that they're trying to make them all the same length, it's that they're like 038.49 is a code, 038.5 is not a code, it's actually invalid. And then 038.40 is different from 038.4.
Yes. Well, what that means is that's really what's going on. It's a hierarchy.
Yeah, exactly.
So, but
It's
we're not gonna tell them, oh, you can put your dots in and we'll figure it out. They have to follow this format.
Okay.
They have to. It's too much for us to do it, and people should know how to do it. And in fact, I guarantee you, they created the ICD-9 grammar and 10's grammar specification with the paddings on the left in order to account for vectorizing these hierarchies into linear strings like this. So this file right here, which was included as part of the download, has to be imported like this previous to running this thing. And then you have somewhere floating around, it's right here. That one was the hardest thing for me to figure out. Once you import it, there is a hard-coded lib name called library, which it will look in there, and if it finds something called formats.sas, it will use that format to look up that format right there. Okay. That took me a long time because whenever I deal with programming languages, I'm always concerned about context and scope. Where did context and scope, like you asked, where did this diag come from? Where did this diag type come from?
Yeah.
I could answer all of those questions for the longest time, except for these formats. I was like, where the hell are these formats coming from?
Yeah.
Well, it turns out if you have a lib name called library, which is just a folder, and if you have a formats in it, that will be where SAS looks for those formats. It took me a long time to figure that out. Okay, so repeating here, what we did here is we macro substituted this thing in here, and then there was so this one was what, y to whatever. It is a key. It is a key in a kind of a hash table. So this is the key. I'm sorry, this is the key, and this is kind of like the name of the hash table. Put turns things in is the one that turns things into characters, but when you use it with a format, it's actually like a hash table lookup. Left just says, hey, this is a new variable we haven't introduced into our scope. What is its length? Well, its length is the same length as what was in here. That's all it's doing, because lengths matter in SAS. Input then turns a character into a numeric. And so it says, turn this, so if we put in a diagnosis of what would it be a diagnosis here? A diagnosis would be
250.
250, whatever. Then the output would be, I actually had it over here. Then the output would be, if the input was 0205, the output is 115, which is the code category.
Yeah.
And that code category, let's go right back here, we're going to turn it into numeric. And it has 4.
So it become 115.
Yeah.
Dot 4. Dot 0.
Dot 0. Yeah, well, you don't even need to put a dot 0. The dot here means that there is nothing after it. It's just an integer.
Okay.
So that becomes what's called input diagnosis, which you can see right here. The ultimate thing to do is this. So now we have an array of code categories, and we say the array at location 115 is assigned to equal to 1, which is another way of saying 115 is true.
Yeah.
It's kind of like a bit mask.
Yeah.
That's really all this is. So C is a list of all the code categories that this patient has.
Yeah.
And remember, this C gets retained every single time through the loop because
you told it to.
Because I told it to retain all of its variables here. Because we're retaining CC1 through CC201, and these are the elements of C, then they are implicitly being retained. So for every diagnosis, we are building up this C array. Ones indicate you have this code category, zeros, because remember we started it by zeroing it out.
Yeah.
The very first time, we don't know any code categories because this person probably doesn't have any diagnoses yet. Now we're building them all up. And this thing goes through the loop, and we keep on building them up, keep on building it up. That means if you have several diagnoses, different diagnoses, which map to the same code category, that information is lost because that code category will just get the 1, right? Yeah. So that's one way in which we quote lose information. But that's the point of categorizing. Categorizing creates larger scale grains so that we lose information on purpose.
And it's interesting that we did this so that the identified CC, which is IND, is greater than or equal to 1, which they all would be greater than or equal to 1 because they're all like.
Oh, you're talking about this right here?
Yeah.
Yep.
And then if that is less than or equal to the total amount of CCs, which it always would be.
The only reason they do that is because they create this at the top. So this is a way of resetting your CC variable every single time. To initialize it, you set it greater than that, which is always greater than 201.
Yeah.
And it can be that in the editing, you can set it equal to -1. So by setting it outside less than 1 and greater than 201 by being either 9999 or -1.0, we're essentially saying don't do anything with it.
And there's like what this makes me think of is there's a cool pandas function.
Mm-hmm.
So NumPy, and NumPy is the same thing. So that the CCs that a patient has is like a long array, and pandas and NumPy allow you to functionally convert the entire array to booleans based on criteria.
Yep, that's a map function.
Yeah, exactly. So.
Yep, it's a map combinator, which is you begin to see as you do different programming languages the abstraction that matters, and in that case, what you're doing. And in fact, you can claim
probably SAS has it in 9.5.
Well, the data step is that. Remember, the data step is the thing that's being iterated on top of the loop. It's like the closure that's being iterated on top of the overall structure.
Okay.
It just occurs that there is another array within it. So you would have a map within a map within a map.
Yeah.
So that's the bulk of what we're doing is there, right? Now there's some editing. Actually, let me point out that there are some subtleties here. Notice this thing called primary assignment and duplicate assignment. The reason for that, it took me a while to figure that out, is it's not a one-to-one relationship. I'm sorry, a many-to-one relationship between diagnoses codes and code categories. It's a many-to-many relationship. So I'll show you an example. You see this right here? We're saying the diagnosis code 3572 can be both a category 18 and a category 75. So that is the difference between, here's our primary assignment, and then here's a duplicate assignment. I'm sorry, there are 2, and then here's a secondary assignment. In the case of ICD-10s, and I'll show you right here, you will see, I guess ICD-10s are allowed to assign to 3.
I didn't know that.
So remember I was asking you a couple weeks ago what that D means? That means it's a duplicate. So it creates a many-to-many relationship, which is interesting, but potentially that stuff gets fleshed out as part of an edit. So that's the last thing I want to talk about in this section right here. So the bulk of it is just a lookup to say this diagnosis becomes this code category.
Okay.
But at the very top, there's this thing called edit, which is a special set of code that does demographics and age edits based on certain types of codes. And this one is going to be a little bit problematic. Maybe some of this stuff we will not be able to get done yet. Let me show you what it looks like. Over here is the editing for, I think, ICD-10 codes. Most of it's easy. If female and this ICD-10 is either one of these, then our code category is 48.
Yeah.
These are just one-off edits. Otherwise, do this. It's this stuff that's going to be, that's opaque. This stuff says, if I have an ICD-10 code like this, then use this. Remember, this is like a lookup. This is like a hash table lookup. So if our ICD-10 code is whatever it is, let's say 233, then using this format, look up some sort of special age thing. And then using that some sort of special age thing, there is an upper limit and a lower limit in which that ICD-10 code applies. So for each ICD-10 code, there's a lower limit and an upper limit for their age to apply. Otherwise, it gets narrowed out to a negative one, which means it's outside. Which means that code category is not set. The reason why this is, and then we use that right here to pull out that value. Okay. The reason why this is problematic is what hasn't been exposed. The CMS guys were very nice about exposing the formats, like the crosswalks as text files here, but they have not exposed the age limit and age. I don't know what these are. There is no text file that explains these things. It's all captured in that binary file.
What?
Let me repeat that. For the crosswalks, which we saw over here, which had this put, they were kind enough to have created a separate file saying, oh, inside that format file, which is a transport file, which is a pain in the ass to read. Here are what's in that crosswalk. You don't actually have to open it up. It's literally just text. Right. Here are ICD-10s to code categories. Here are ICD-9s to code categories. In the case though of the upper and lower age limit per ICD-10 code, that's captured in a format file, a binary transport file, but it's not in a separate text file. I don't know what those are. So per ICD-10 and per ICD-9 code, there are upper and lower age limits that matter, and there is no way for me to know them unless I write some SAS code to iterate through every ICD-9 and every ICD-10 and print out those upper and lower ages to a separate file. Then I can use that to bring into the Python code.
Yeah, that's a good feature.
That's what I will do eventually, but it's just extra.
Yeah, right. Because you have to open it. It's that HSEX_v2.sas, right?
No,
same way the score var.
No, it's not. That HSEX, that's a separate thing altogether. This is a format right here, and that format and this format right here are captured in this formats.sas.
Right, the way the coefficients work.
Yes, but the coefficients are in a separate transport file.
Okay.
There are two transport files. They make that clear over here. There is a transport file that captures the coefficients.
Yeah.
And then there is a transport file that captures the formats.
Yeah.
I can get the coefficients easily because I've imported the coefficients, which allows me to do this, which allows me to go to SAS code and click on it, and then I can see every single coefficient.
Right.
And so I could just say, save this as a CSV.
Right.
But
because
formats,
it's deep into formats,
because formats you can't actually view.
Yeah.
Well, maybe let's see if view file as text. What happens there? I might kill it. I think I just killed it. Yeah, I shouldn't have done that. Anyways, yeah, that's what it is. So you can see there are age. So there are categories of 0, newborn, 1 pediatrics, and age and upper lower limit. It's
okay.
I need to write SAS code in order to extract that stuff out.
Yeah, feature. Great feature.
Yeah. So just to repeat, we were here going through what happens every single time we go through. And what it is, well, we do some edits, and then we assign some cost categories.
Yeah.
And that's done through every single time.
Sure.
Now, finally, if it's the last record, again, we're in an implicit for loop. So now let's do something. This is all the stuff that happens on the last record. Now that we've created an array per beneficiary of all the code categories that they have, we're going to do multiple things. And they actually explain it very well. We're going to create demographic variables. We're going to create HCC. We're going to create HCC interaction variables, HCC disability variables. And then we're going to run all 3 scores on this person. So remember, we were talking about that yesterday. All 3 of them are run. It doesn't matter. Okay. It's up to you to decide, is this person an institutional patient? Is this person a new enrollee?
That makes it easier.
Yes, exactly. We're not trying to figure out before they go in. We just calculate the score to say if this is a new enrollee, and you can do it that way. So now, this is the last thing what we do here. So again, their code comments explain it. We create demographic variables. That's this right here, the age sex macro.
Yep.
The age sex macro literally does two things. It takes your age and puts you into one of these buckets.
Yeah.
So if you're age 6 and you're female, you're going to fall into this bucket. It will also put you into this bucket because it doesn't know if you're a new enrollee or not. And the reason these buckets are different from new enrollee buckets is the institutional and the community
Use the same.
they have a 60 to 64 bucket, whereas the new enrollee bucket breaks out 65, 66, 67, 68, because the new enrollee probably, there's a distinction for each year there. We're getting it.
Yeah, we're getting it. Good. So the OREC that you read in is not used for anything?
It is. It absolutely is. The original reason for entitlement is
Oh,
used.
yeah, no, that's something different. Right. Yeah.
Yeah.
Okay, yeah, that's a later variable.
Well, it's actually used in this file right here. You can see right down here. If the original reason for entitlement is not equal to 0, and they actually explain what the original OREC is a for what's called in statistics is called a dummy variable. You can call it an indicator variable, but it really has 4 values: old age, disability, end stage renal disease, or both disability and end stage renal disease. So if that occurs, if you are 64 and your original reason for entitlement is not old age, we're going to say you fall into one bucket. I don't know why they do this, but they do. So they're putting you into right here. It's a little bit redundant. See this 60 to 64. Oh no, I don't know why they do it. 1, 2, 3, 4. Yeah, I'm not exactly sure why, but all it does is basically puts you into another bucket. So
no. The reason they do that, go down to that line.
Mm-hmm. They're putting you into bucket 5 or into bucket 6.
Right, because you can't be a new enrollee because it's Medicare.
Mm-hmm.
So you can't be like 68 and a new enrollee.
Gotcha.
It has to do with that, and they know what that is.
It's an edge condition. It's an edge condition around the age 64.
Yeah. Because
this is bucket 5 and 6, and bucket 5 and 6 you can see is 1, 2, 3, 4, 5, and 6.
Right.
So this is the edge condition right here. And I could sit here and think about it for another 5 minutes and figure it out. Yeah. But just as we did before, there are some tricks here. We've created 2 arrays called cell and new enrollee cell that have these elements in them. And all of this is that garbage SAS stuff in order to just say, assign someone. Yeah. This is another way of doing a dictionary, but this is reverse. This is putting you into a dictionary. Sure. It's just but it's garbage, And so that's what it's doing. If you're female and you're between the ages of 0 and 34, then you belong in this bucket. And then we put that bucket into cell 1, and that bucket is female 0, 34. We've given you the value 1.
Yep.
No. We've given you the value 1. You see what's going on there? We're saying if age sex, let's say that was an 8. If age sex is equal to 8, if 8 is equal to 8, this is a Boolean comparison, and that turns it into a 1.
Yeah.
So ultimately, everything that gets set into cell 1 through 24 are either zeros or ones.
Zeros or ones.
Yeah, that took me a while. Whenever you see that, this is a Boolean comparison that gets turned into a 1.
Yeah.
Same thing happens here with the new enrollment cell. And so I said this age sex thing is doing 2 things. It's putting you into buckets, age sex buckets for both regular and for new enrollee. And it's doing one more thing, and it's this right here. It's saying, are you disabled or are you originally disabled? And this is based on this OREC thing that was passed in for each individual as part of the input. That's all.
Okay.
So again, age sex variable sets these things. And in the end, these are values to the linear regression.
Yeah.
Okay, so to repeat, we're back in our main code here. Our main code is doing the last time. So we've created now age, sex, demographic buckets and originally disabled. So that's the first thing we do. The second thing we do is do what are called regular interactions, which are just, are you disabled along with, are you on Medicaid along with your age, with your sex, not age sex.
Yep.
So this stuff took me a while to figure out. I thought there was some sort of numeric calculations going on here, but this is all Boolean algebra. That's all it is. MCAID is either a 0 or a 1.
Okay.
Sex equals to 2 is a 0 or 1. Disabled is a 0 or 1. So if it's a 1, 1 minus 1 becomes false. So if you're Medicaid female age, that's because you're Medicaid, 1.
Yeah.
Your sex is 2, that means you're female. And if your age is separate from disabled. So if you are not disabled, 1 minus, if you are disabled, I'm sorry. I have to look what it is. I guess if disabled is 1, that means you're not disabled. If you're disabled is 0, it means you are disabled. Then it says you're a female age. And so all of this stuff is just trickery because SAS doesn't have an inherent Boolean type.
Okay.
And we're using what are called indicator variables or dummy variables
Yep.
and multiplication to coerce these things. So Medicaid female age is either 1 or 0. Medicaid female disabled, if this one is 1, then this one by mathematics has to be 0.
Yeah.
And so that's what we're doing. We're creating interactions. And that's just a hoity-toity term for saying, is this person both Medicaid, female, and age?
Yeah.
Is this person Medicaid, female, and disabled? All the way down here. So these are the normal interactions based on whether it's Medicaid or disabled. And now we have new enrollee interactions. These apply for community and institutional regression. These apply for new enrollees. They're a little bit more complicated. Female between the age of 65 and their new enrollee Medicaid is whatever. And so that's all these things are doing is some sort of special code that gives these things here zeros or ones. Now, remember I said maybe about 10 minutes ago that everything in SAS that's on the left hand of an equal sign is implicitly going to be in the output data set.
Mm-hmm.
So these all become columns in our output result. And they're all going to be used in our scoring too. That's probably the more important thing, but they're also going to be columns in the output.
Yeah, so when we talk about the 2017 software, just this is where it
will change a lot.
Yeah, this is where it changes a lot.
That's a very important thing. As I was reading through this code, I was trying to understand what are the things that are probably going to be constant, that are probably going to be consistent, and then what are the things like this that are going to change as the years go on, and they'll publish new things. So I think how you roll up code categories is something that's going to be changed, but also these edits and these interactions.
Okay, so let's just talk about this briefly.
Mm-hmm.
They are doing the exact same thing. They're just doing more. So instead of new enrollee and enrollee, they're doing or instead of doing age and then the new enrollee buckets, they're actually doing originally disabled new enrollee,
Mm-hmm.
not originally disabled new enrollee. Then they're doing not originally disabled Medicaid enrollee.
They're doing that here too.
Yeah, it's just they're doing that with age buckets. So instead of 2 sets of full age buckets, like go back to age sex, the age sex macro. In age sex macro, you have
2 sets of buckets.
You have 2 sets of buckets.
Yeah.
In the 2017 version, there are 1, 2, 3.
Oh, they break it out
4, 5 sets of buckets.
I think that's probably very close to what they're doing here by multiplying it out. Notice these buckets here are originally disabled. But yeah, there are so many different ways of combining these things. And unfortunately, because of all these things, the proper way to model this in software is to make that into an object and these as attributes off of it. What they're doing, though, is because they know it's the input to a linear regression, they're treating these as all separate variables with a coefficient. And so you get this massive explosion of combinations of 3 interacting variables or 4 interacting variables. You can get an explosion of these variables into a linear regression.
Yeah. So then the other thing is they don't have as many. So they don't have these as many of them because they're just doing full buckets across each category. They're saying Medicaid buckets, new enrollee buckets, like all the way across because they're calculating more scores.
Mm-hmm.
So they are just creating more variables. These variables for this score, these variables for this score, and just go through all of them. But what they have more of, which is we're going to do next, is they have a ton of. Actually, it's not as many. They have more of the disease interactions, which are lower down.
Yeah, you'll see the disease interactions coming up. Yeah, so far this has been only regular interactions based on age and demography.
Yeah, so a lot of these have been eliminated because they just are doing just bucket everything.
That's going to be a pain in the butt.
Yeah.
All right, so again, create the regular age, sex, date buckets, create some basic interactions with Medicaid and disabled. Now, so notice here it says if N1 and N2. Well, I was like, why did we have to have this? Because we were already protected by N1. But this says, what this line is saying here is if there is a diagnosis. If there is no diagnosis, then we're going to have to, at the very end here, just say, where is it? Sorry. There are no diagnoses, then our HCCs are 0. So that means we have beneficiaries who they still matter. We can still give them a risk score. So in case there are no diagnoses, this matches up here, then their HCCs are all 0. But if there is an N2, then do this.
Yeah.
Okay. So Same thing was occurring. Oh, one more thing. Up here, you notice that sum?
Yep.
That's because, look, these things, truth in SAS is anything but 0.
Okay.
So if any one of these things is 1, then they're all 1. So you could actually sum this up and get 6. So which just becomes true. So 5 and 1 is true.
Yeah.
So now we're going to do interactions with diagnoses. So we're going to say max HCC. Oh, but I skipped over something. How did we get this HCC? Well, let's scroll back to the top. Where did we, in fact, get these HCCs? Oh, right there.
Yeah, you do the higher MAC.
If we have that defined, invoke higher MAC. So higher MAC is here. Higher MAC does this. First, it sets the HCC array to the same as same. So if we had a 1 in the 3rd position and a 1 in the 15th position of our code categories, the HCC will have that. Then, and now I finally understand what they mean by hierarchicalization. Then it says, if you have an 8, then 0 out 9, 10, 11, and 12.
Yeah.
Because 8 is the more severe version of neoplasm 2.
Yes. Yeah.
So I didn't understand what hierarchicalization meant until now. So that is actually coming here from this. Set 0 is this.
Yeah.
So if 8 comes in here and higher is 9, 10, 11, 12, if HCC at that value, HCC 8 is equal to 1, then for HCC from 9, 10, 11, and 12, make those equal to 0.
I thought this was oddly elegant for SAS.
Yeah, it's pretty good. Like I said before, the code is shit, but not because of the programmers.
Yeah.
The code is shit because it's SAS. These are excellent developers. Whoever wrote this, they're good SAS developers. I mean, they've taken it as far as you can, but it's very elegant, and that's all it's doing. But also notice you have to do it in order, because first we have 8, and then 0 out 9, 10, 11, 12. If I were to cut this here and put this above, it would create a bug.
Correct.
So they have done it with a specific order. So if you have 8, 0 out 9, 10, 11, 12. If you haven't 0 out 9, 10, 11, 12, but you have 9, then eliminate 10, 11, 12. Mm-hmm. This says get rid of the CCs and set these to HCCs. I'm gathering you knew this very well.
This was an easier macro to parse.
Yeah, I didn't understand it at first, but that's all it's doing. So back here, we run that thing, and now these are very high level interactions. I was reading the HHS spec on it, and these are called like severe. I forget what they're called, severe something. In HHS, there are 8 of them. Here, there are 10, I believe. And max again is just literally, so if there is 0, 0, 1, 1, 1, then make it a 1. So if you have any of these set, then you have cancer. If you have any of these set, then you have diabetes. And the reason these matter right here is because we're going to use them in interactions. Again, this is just Boolean algebra. You see the multiply and you think, oh no, there's something really numeric going on. No. All we're saying is cancer immune, is that a 1 or a 0? Diabetes, CHF is, what is CHF? Shoot. I always forget what that one is.
Congestive heart failure.
Congestive heart failure. And coronary obstructive pulmonary disease is COPD. Yeah. So if you have both of these, that's because 1 times 1 is 1, right?
Yeah,
and then we do the same thing. Now, everything in this block is interactions with diagnoses and HCCs. And all of these things on the left hand of the equals are output variables, and all of these things will be fed into our scoring linear regression model.
Okay, so they did the same thing. Yeah. 2017 has a couple more, but nothing. Like there's new ones for substance abuse and respiratory dependence.
So I saw substance abuse going into the HHS stuff, but it's also going to the Medicare stuff too?
Yeah.
Okay, that's cool. Yeah, and so they keep on creating more and more of these things. All of these ultimately are, as I said, anything on the left hand of the equal sign is an output column. And then once that's all done, we're done. Now scoring. And we're going to score 3 of them. We're going to score community, we're going to score institutional, and we're going to score new enrollee. It's worth pointing out something right here. See the score mac? This is literally replaced with the score macro, which is right over here, which will be score var. This are the inputs that matter for community. These are the inputs that matter for institutional, and these are the ones that it's worth looking at these here. The community reg, all the way at the top, has been set at age, sex, female aged, plus all these things, interaction variables, and then all of our HCCs.
Yep.
Institutional reg is age, sex, Medicaid, originally disabled, interaction I variables, and our HCCs. And here's something interesting. I didn't get it at first, but now it makes sense. New enrollee reg, if you look at those, it's pretty much the same, except it doesn't have
HCC.
HCCs
Because they have no history.
because they have no history. So when we do a linear regression score on new enrollees, it's literally on the only thing we know about them, which is their age and their sex and their Medicaid, because they are absolutely new enrollees, no history. I was so very happy. I patted myself on the back that I finally understood that. But again, so the second parameter is what is going to be used to score. Notice this thing right here, the third parameter, CPref, which is coefficient prefix. So CE.
All coefficients with that prefix.
Yep. So ints underscore and any underscore. So in the score var right over here, what we're going to do is, here's our R list, the things that matter, input. Here are the coefficients. And we literally multiply them together. This is probably one of the only locations in all this SAS code where this multiplication is being used for non-Boolean algebra. This is the linear regression. This says, here's our input. Our input is R list. R list was age, sex variables for community and institutional plus all those interactions. Every single thing in here is going to be a 1 or a 0.
Yep.
That's the clever thing that they do. So this is a linear regression that basically uses indicator categorical dummy variables.
Yeah.
And then we're going to use CPref. So CPref will become either CE underscore or INS underscore. And as I showed you before, when I loaded those coefficients, I'll load them again. You can see, so that is the VAT CEFO. This is a massive single row of every single. So what this does here is it scans for times CE underscore scan. Oh, maybe I don't quite understand that. Times, oh yeah, that becomes CE. Scan is a macro, so we're scanning the R list for that thing. So we'll actually put in, sorry, where is it? Where are those? Right there. So we'll actually put in HCC because it's a macro 188, and it's another way of doing those things.
Can you go back to the coefficient file?
Yeah.
Can you go to what are the rest of the columns on this?
All the stuff you see right here. These are all the interactions possible, whether they be non-diagnoses interactions like this, or whether they be diagnoses interactions like this.
Okay, so one of the things I'm looking for that we haven't found yet is the CCs. Where are the CC labels?
They are not here.
Right.
They are no CC labels.
We have to find the CC labels.
That's not in the SAS code whatsoever. We'll have to pull it down from somewhere else.
I don't know.
There are HCC labels, but not CC labels.
Don't know where the CC labels are,
Mm-hmm.
because one of the benefits of our library is sometimes not the score, but just what conditions does this patient have, right, for categorization.
That would probably be a one-time download of a mapping of code categories to their labels,
Right.
and then we can do that.
And somebody could say, give me the level 1, which would be the HCCs, or give me the level 0, which would be the CCs.
Mm-hmm.
And according to Accordion's demo, they have that. But I'm like, where did they get the CC labels?
Yeah, you could just write a program to RESTfully call those online. What is my code category? I thought those existed. Like you have ICD-9s as well.
Yeah.
So
Yeah, that's a very good point.
once you have the data, you have it. Unless someone's written a special copyright saying you can't use these again.
No, that was a very good point. I forgot about that.
So, anyways, that's pretty much it. And this score var is done 3 times in a row. One for, and so this variable is being set. So it starts off at 0. And let's go back here. So score community starts at 0, and then iteratively is either 1 times 0, 1 or 0 times that coefficient. So the things that have a 1 on them are contribute that coefficient's worth of inputs to the final score value. And then at the very end, we are left with score new enrollees, score institutional, and then they have this weird thing called this, normalize the score. There's this thing called DF. It's set automatically to be 1, but it is a normalization factor. I couldn't see any documentation on what that was.
It's 1 here as well. 2017.
Yeah, so it's scaling all these things to 1.
Oh, yeah, okay.
But apparently you are allowed to, when you invoke it, you could set it to something else. Like I could say df is equal to 0.5. Where's equal? If I wanted to.
Yeah.
I don't know what that means though, but it's there. And it goes to show you there are a lot of things about this. Calling this is the user's responsibility. So the user can choose, I want more things or less things to be reported out. I want to do edits, or I don't want to do edits. Or, Yeah. Or here's where I was telling you yesterday we were doing something wrong. Look at this. This is being run as of the 1st of February 2016, but this was data from 2008 and 2009.
So that's how we got it.
So we should have said 2010, right?
Yeah.
Because then they would have been 65 as of 2010,
Right.
not 70 as of 2016. But that's not the problem with the dates. The problem with the dates was we fed them this data. If you look here at their beneficiary file, see their date of birth, 192-1923-0501. That's year, month, date format. That is not the format that SAS wants. SAS wants the number of days since January 1st, 1960. So I have to convert it into that before it will actually.
Really?
Yes. Yes. There are some things like this right here. If you do this, if you write it in this format and then put that D out there, it will convert it into the number of days since January 1st, 1960. It's a very different format. So I actually missed that, but it was actually here. They did say this right here. Date of birth, SAS date format. And you have to look up what SAS date format is. And again, SAS date format. Remember, SAS only has two types, numeric and char. And so date is numeric, and it's the number of days since January 1st, 1960. Not 1970 as in like Unix Epic, 1960. Again, showing you how old SAS is that they chose to make it that. I think SAS was first written in like 1969. And really, that's it. At the end of it, we've scored it. This is the end of our data step. Remember, data step is pretty much all of theirs in SAS. And now that we're done, we print it out and we create an output file. And there are other things in here like the labels, but you saw that automatically. Label is a way of attaching these things. It puts metadata associated with each variable. It's a particular foible. I'm gonna keep on using that word. It's a particular characteristic of how SAS does things. Data sets have metadata associated with each column. And in this case, you can give it, quote, a label, which is used in reporting out things. But you were asking, we have labels for the HCCs. We don't have labels for the CCs. And that's pretty much it. Unless you have any more questions, I'm going to stop the recording.
No.
Okay. Oh, I will keep this on the recording. Let me show you this, Luke. So I wanted to translate this high-level code that we saw here, which they did a pretty good job commenting. I showed you how they had the 3.4, 3.5, 3.6. Mm-hmm. Here is what I have. This is our Python code as a set of very high-level steps. What will do the same thing. I copied their pseudocode in here. So realistically, score beneficiaries follows the same right here. I will center right here. Score beneficiaries. A beneficiary has a beneficiary, and the beneficiary object has diagnoses. Mm-hmm. It's the same thing as the merge. Mm-hmm. In the case of Python, someone will have pre-created a beneficiary and all his or her associated diagnoses. So we don't need to worry about the mechanics of a merge. Okay, so for each beneficiary, for each diagnosis, edit the diagnosis. This is either edit Mac 9 or edit Mac 0, and create the category coding. Notice for both of these, I pass in the beneficiary and the diagnosis because when we edit the diagnosis, we assign the code category to the beneficiary. These are rolled up to the beneficiary label. Then we create demographics on the beneficiary. Then we create HCC because this is an object. This beneficiary has the code category on it. We create the HCC, then we create the interactions, then we create the disabled interactions, then we score it. Score, if you see here, returns a triple. This is fake for now. This will be the community regression. This will be the institutional. This will be whatever. And then I will return results, which are the beneficiary and all of his or her diagnoses along with their scores. And then those results I will output to something. So this right here is essentially what was in that data step.
Right.
I mean, obviously, it's going to get much bigger, but the Python reads so much like pseudocode that this is already an advantage for anyone trying to understand it.
Right. And then the other thing to keep in mind is just like they'll need to be able to access the conditions underlying it too. So they'll need to be able to say, what conditions does this beneficiary have?
Yes, yeah, and those conditions will be on the beneficiary him or herself. So they'll have the conditions, and they'll have the HCCs, and there will be an array of all the diagnoses.
Yeah.
Yep. Okay, now I will stop recording.